Hello everyone, this is question 7A on the practice exam. In this case here you have to draw the following, or the structures for the following compounds. There's a lot of them and I'm not going to write out all of the names because they're long and you have them right in front of you hopefully. So the first one is 4-isopropyl 2,4,5-trimethylheptane. Focus on the end, heptane, that's telling us it's an alkane and there are 7 carbons. So draw out your chain. 1, 2, 3, 4, 5, 6, 7. And now focus on the substituents that you have on there. You're told you have 4-isopropyl. You can see you also have a 4-methyl, right? So 1, 2, 3, 4. So I'm going to have 2 substituents there. I'm going to have an isopropyl, which is drawn like that. Well, straight line, not the way I drew it. And a methyl, which comes off like that. We also have 2 more methyls on carbon number 2 and carbon number 5. So 1, 2, and 3, 4, 5. So there's the first one. Now, the second one, 3-bromobenzoic acid. When you see that oic acid at the end, that's attached to the other main part of the molecule. That means it's a carboxylic acid. So benzoic acid going to have a benzene ring, which I'm drawing like this. You could also draw it with the double bonds, the 3 sets of double bonds, but know that those are delocalized. So you have resonance, and so we show that delocalization with this circle, meaning those electrons are free to move around in those pi bonds. So we need a functional group, a carboxylic acid functional group on here. So let's just put C double bond O, OH, there's our carboxylic acid. There's our main benzoic acid, and we're told that we have a 3-bromo on there somewhere. So this becomes carbon number 1, the one with the functional group. Then you just work around and you can go either direction. You can have the same thing. So 1, 2, and I want that to be 3. There's my bromo. Okay, this will be carbon number 3. You could also call that one meta-bromo, okay? So if it's in that meta position, remember this is ortho, meta, and para, okay? Now, let's do the third one. Third one is butylmethylamine. So amine is telling you you have a nitrogen in there, right? And you're told, if you look before the amine, you can see 2 separate alkyl names, a butyl and a methyl. So you know if you have an amine, you have a nitrogen, double bond, and it has 3 things coming off of it. So one of them will be a butyl. So this will be carbon number 1, 2, 3, 4. One will be a methyl. I'll just put CH3 in here. It'll be fine if you leave it open as well. And the other one is not telling us, that's going to be a hydrogen. And you do need to specify and show us that you have a hydrogen on there. Otherwise, if you just leave that line blank, it might mean methyl. And now the last one, N-ethyl pentamide. So the ending pentamide means that you have an amide. And the amide, or amide, depending on who you talk to, for that group there, looks like this somehow. Actually, I shouldn't put an H in there yet. You somehow have this functional group in there. So your carbon has a carbonyl on it, and it needs to be bound to something on this side. And it is bound to a nitrogen, which is an amine function. So it's going to have 2 more bonds on there, has its lone pair up there. Okay. Remember, this came together from the reaction of a carboxylic acid on this side. You split this guy down the middle, and an amine. So the first part of the name, or say the part of the name that's attached to that amide, so the pentamide, comes from this side here. That means we're going to have pent. We're going to have 5 carbons on this side. There's 1, 2, 3, 4, 5, however you want to draw that out. Okay. And over here, and actually they kind of specified it a little bit more. They said N-ethyl. So they're telling you that on the nitrogen, there is an ethyl group. 1, 2. That means this last place here is just a hydrogen. So there's 7A.